Hey guys, so this one, I'll need a little bit of help numbers-wise from you guys. Rate of change of altitude is given by that function right there for 0 to 8. Which of the following gives the change? So when you guys see this phrase right here, gives the change in altitude, would you say that that is a rate of change or an amount of change? Definitely an amount. Yep. So that's the amount of change of the balloon's height during the time the altitude is decreasing. So let's look at this right here. When would altitude be decreasing? Like, what would be happening then?
Altitude is negative.
The rate of change of altitude would be negative, yeah. So R of t would be less than 0. And so what I'm thinking, in order to find the appropriate interval here, I should probably use my calculator and graph R of t and find out when R of t is negative. So it is a cubic, and it's a cubic with a positive lead coefficient. And so, can I just peek at a graph here real quick? Nobody has it up.
I cleared it.
Nobody has it up. Ah, there we go. Okay, so is that 0 to 8 right there? Yeah. Okay, so from 0 to 8, thank you, Rachel, it looks like this. Right? Yeah, roughly. So then the area that we are interested in would be down here, because this is a graph of R of t, and since we're looking for where altitude is decreasing, we want to know where R of t is negative. So anything below the t-axis would indicate that R of t is negative. So it looks like it's just that stretch right there. So if I could find this and this, that would at least give me the interval that I'm interested in. So I am assuming that somebody in here has those numbers. What's the low number? 1.57 approximately. How about the other one, the higher one? 3.51. Okay. So in all honesty, doesn't that eliminate B and C and E? At this stage, we're just down to A and B. So then the question is, to find the change in altitude, should I be doing a definite integral of a rate or the definite integral of the rate of a rate, right? That makes sense? Because R of t, maybe this is potentially the confusion, isn't R of t already a rate? And so what would R prime be? That's a rate of a rate. So really, in the context of this question, wouldn't R prime be the acceleration of the balloon? Really, I mean, sometimes we overuse the word acceleration, even when we're talking about stuff that's not moving around. This is a case where this is appropriate to say that's acceleration. And so this comes down to the definite integral of a rate gives the amount of change, not the definite integral of an acceleration giving the amount of change. So because of that, I think I would also cross off D and go with A. Does that make sense? Any follow-up questions to that? Okay, awesome. Let's see how you're doing, and we'll move on. Okay, your mom continues to lead.
Yes.
Awesome. Here's question 5. I don't know, I'm hoping someone just made a little mistake. 5 seconds, time to guess. All right, good job.
Yeah.
All right, pretty good. Number 6, halfway there. Time to guess. Okay, not bad, not bad. Anybody want to go over that one? All right. Say again?
Someone wanted to go over it?
Yeah. So it looks like it was mostly E. Okay. Again, I can definitely, we can talk about the concept here, but I'll need a little help from you guys on specific numbers. So it says the pizza is heated to a temperature of 350 degrees, taken out of an oven. What is the one piece of information in this question that is completely unnecessary? The 75 degrees, right? I mean, we're assuming that the room that the pizza is placed in is not 350. It's going to be less than that, I would guess, right? So 75 is a reasonable temperature, but whatever it is, the most important thing is the rate of change of that temperature once the pizza is removed from the oven. So as far as like a concept goes, we could say this if you wanted to. You could say the original temperature of the pizza was 350 degrees. And once that pizza is taken out of the oven, isn't the temperature going to go down? It's going to decrease. So I think I would say 350 minus, and then I was given a rate of change of temperature. So in order to find the amount of change of temperature, I need to integrate that, right? I've got to do a definite integral. So I think I'd go integral from 0 to 5 of negative 110 e to the negative 0.4 t. I guess that makes sense. Yeah, dt. So, yeah, when you integrate that and subtract from 350, this should lead you to the right answer. Yeah. So E was the more common wrong answer. What was the right answer on this one? A. Okay. So help me out, E people. Will you help me out? Like what?
I did mine about negative 885.
You plugged the 5 in for the T and got roughly 15? Got it. Okay, so you just didn't recognize it was a rate. Got it. Okay. Thank you. Any follow-up questions? Thanks for not being shy about saying, yes, I'd like to go over that. Sometimes it's not a big deal. Sometimes it's a big deal. All right. Yeah, they treated it like, they treated that function like it was like an amount of change. Yeah. All right. There you go. Question 7, second half. Here we go. Oh, goodness. Oh, this is the worst one. Sorry.
Read that out.
You just have to give us an answer.
Yeah. Hey guys, I'm happy to read it out loud for you too. If a trapezoidal sum over approximates the integral from 0 to 4 of f of x, and a right Riemann sum under approximates the same integral, which of the following is a graph of f of x? So a trapezoidal sum is too high, a right sum is too low. Which of the following could be the graph of f? Sorry for the smallness of the writing. Man, I can't read that from back there. Trapezoid sum is too high, right sum is too low.
You done this?
You see, if this were a D.B. test, that's right.
So if the right sum,
Just erase it.
yeah.
You know, this year on multiple choice.
Yeah, you're committed. Once you know, you have to like punch it out with like a little paper gun.
Oh, I'm still at first.
Yeah, yeah. Hey guys, was this a size of writing issue? Hey, you want to go over this one? Yes. Okay. Sorry about the small writing. This was 7. This would have been a little easier to read, huh? Okay. Hey, so guys, to me, the easier place to start is to start with the fact that the right sum is an under approximation. So a right sum will be an under approximation whenever the function you're dealing with is decreasing on the interval that you're looking at. So, and we could illustrate that and say, you know, like here, you can see a right sum is going to be too low. Here, a right sum is going to be too low. Over here, on these increasing functions, a right sum is too high, isn't it? So that's why I would say, as you think this through, if you can identify the right sum under approximating as being a decreasing function, what you could then do is eliminate all of the increasing functions. All of those make no sense in regard to, in regard to that. But then the trapezoid sum, maybe you got A and C sitting right there. The trapezoid sum is a little bit different. So maybe you draw in a couple of trapezoids. So if I was going to draw in a trapezoid over here, a trapezoid would maybe look like this, and then like this. What does the accuracy of a trapezoid sum depend on? Not decreasing or increasing, but, say it, concavity, yeah. So you can see that when you've got a concave up function, then the trapezoid sum is too high, but when you've got a concave down function, the trapezoid sum is not perfectly illustrated there, but it's a little too low. So since we're looking for the trapezoid sum to over approximate, I think we go with A. So I think a picture is worth 1,000 words here. If you sketch it in I think you'll have a good chance of seeing it and coming up with a good conclusion. You could have sketched it in on all of them if you were a little unsure. I think you probably would have seen the pattern at some point, but hopefully that would have worked. All right. Here's your leaderboard. All right. Question 8. Hopefully this one is a little bit easier to see. Tan with a little -1 is arctangent or inverse tangent. And that's x-axis on the right edge there. It's not x-dac. X-axis is a square. Challenging one to get done in 2 minutes. AP test, this one you want to take 2 months. Do your best. Hopefully there'll be some others also where you can do them down in like 30 or 40 seconds. All right. Chavo leads. Your mom is now in second place, but barely. All right. There's no Mayas in the top 5 for once. Whoa. Interesting. Interesting. All right. Question 9. Time to guess. Throw it in there.
Yes.
All right.
First, baby.
Questions? Anybody want to go over that one? Yes? Okay. Is that number 9?
Yes.
Okay, I guess, so let's do this first. I'll write some stuff down, then we can use the calculator here. So it says function f has this first derivative given by f prime equals that right there. What is the x-coordinate of the inflection point of f? So let's just think about it like this conceptually. If you have a graph of f prime and you're trying to figure out where f has an inflection point, then what are you looking for on the graph of f prime? Say again? Yes, there you go. There you go, Matt. It's where f prime goes from increasing to decreasing or decreasing, increasing. In other words, relatively high or low point. Does that make sense? So we're basically looking for where the graph of f prime does either this or that. We'd be looking for this and either one of those sorts of things. Does that make sense? So what I would do with this is graph f prime. And if I remember from peeking over some shoulders, if I remember correctly, the graph of f prime does something like this, doesn't it? Is that about right? Okay. So if that's a graph of f prime, then what I'm looking for is essentially where does f prime go from increasing to decreasing on this one. So this is where you really could use that max-min finder to help you find this point. The max-min finder will never be a valid justification for why you found a max or a min. That makes sense? But here, calculator's active. Suppose you could use that. You could estimate it pretty easily. The numbers are all, well, I guess the only ones that you might debate about would be A or B, but I suppose you could even just kind of read across the graph and see it. Which one did it end up being? Was it the 0.4?
Yeah.
Okay, yeah. So obviously you could look at a graph. Does the justification make sense? What we're looking for there? Follow-ups. Okay. Good deal. All right, down to our final couple here. Final 3, I think. Oh, your mom's back in the lead. All is right with the world. All right, last 3. Notice this is one of those ones where they're mixing up 2 different functions. There's an f function, there's a g function. It'd be a bad time to start calling everything f of x like we want to do sometimes. I want to know the equation of tangent line for g. So x equals 2.
Forward.
5 seconds left. Take your best guess. All right. Y'all see the product rule? It's kind of the trick on that one. All right. It's really close coming down the stretch. Last two questions. Here's question 11. Teams have like really improved, or there have been injuries or something. All right.
How is she beating me by 240 points? She wasn't on the leaderboard last round.
You get a streak bonus, I think. She must not have missed any.
That's weird.
You might have to take it outside.
Yeah, we might have to. All right, here we go. Here is the final question. Well,
She clearly attacked.
hey, if she can hack this, then she deserves something.
If I know Caroline, she's probably doing that.
Josh is right. She must have been like in 6th place or something. And did that last one super. We have like a streak. That might be kicked her up there. Last 5 seconds, time to take your guess. Pretty good. All right, let's see what the leaderboard looks like. Caroline, was that really you? Nice. And your mom? Josh, right?
Yeah. I just still don't understand how.
Josh was a little upset.
How am I 400 points behind?
Well, we can take it to a shootout. We'll go to the field after.
Chavo, is that you?
I feel like Chavo should be the real winner.
Nice work. Yeah, he's trying to take credit over there. And the other people in the top 5, Maya showed up. Maya, was that really you? Yeah. All right. And Caleb, were you espresso again? Yeah. Nice. So let's see here. Josh. Is that Preston over there that did that? Which ones were in that?
I don't know. Your guess is as good as mine.
If I went over there and stared at him, I could do it. Hey, nice work, AB people. Way to work your way in. Nice. No, Josh, I don't know what to tell you, man. I'm very sorry. Who are you, just now? Oh, Bad Mama Jam. Okay, gotcha. Well, that does fit you. That fits you quite well. That's the first thing that I think of when I think of Josiah.
She must have gotten the first 2 wrong and then the rest.
Streak
right.
10. Well, she showed up late, I think.
Okay.
Yeah. She might have streaked 10. Yep. All right. Hey, guys, we'll get the FRQs passed out to you now. Mr. Luther, day 3, right?
Yep.
Okay. The grass clippings? Okay, cool. All right. Okay, so Bill, we can start on the grass clippings question. DC people, I'll get you your extra stuff, your optional stuff. This one's calculator active.
Oh, that's what happened to you after.
Oh, shoot. Wait, who said that? She definitely mentioned it to him.
A couple of there's a Libby in there, and then there's one with arc length and all that stuff.
Yep.
So what did we do?
Yes.
Okay, yeah.
That, what you're writing is actually part C you're going to need to do. What you're writing there.
All of Longevity songs have I'm checking these.
A lot going on here for sure, especially with A. This little thing's over. We have to answer questions with that. Scoot over, try to give yourself a score.
Are you breaking up the class?
You ready? Any questions? There's more than one way to get A. Yeah, go ahead. You said D or C? D, yeah. Okay, let's check out D. So D says once you get beyond T equals 30, L of T, linear approximation to A at T equals 30 is a better model. So in other words, they're saying once you get beyond the end of the month, essentially, then the rate of change, or excuse me, the amount of grass clippings is better modeled by a line, a tangent line to A at 30. So it says use L of T to predict the time at which there will be half a pound of grass clippings remaining in the bin. Show the work that leads to your answer. So if we're going to use L of T, then we need to have L of T. So let's see here. I'll just try to squeeze this in off to the side here. So to find L of T, we need to have the slope of the tangent line first. So the slope of the tangent line to A at 30. Does this make sense, Alexander? So you got to find the slope of the tangent line of A at 30. So A prime of 30, I have no idea what that is. 212.5? No, they're doing something different. Do you know what that is?
Negative 0,
5 what?
966.
Okay, I'll go with that right there. Okay. And then you also have to know the point of tangency, right? So you have to know A of 30. So that would just be plugging in 30 into A. And again, you'd want to use your calculator to figure out exactly what that is. Yes, Jeff.
You're kidding. Oh, and then you find that. But then you find the rate.
Oh, 0.0559? Should be an extra zero in there. Okay.
And then you do the rate.
It just subtracts it.
That's so. Yeah. Oh, that's annoying.
That's why.
Is that good? Okay. A of 30? 0.783. Alexander? Okay. So 0.783. So then your tangent line, if you want to write it like with y equals y's and x's, you could if you wanted to. So you could say y minus 0.783 equals the negative 0.0559 times x minus 30. Is that showing up? Yeah. And then it wants to know the time when there will be half a pound of grass. So y stands for the amount. X stands for time. And so I would plug in 0.5 for y. And then solve for x. Does that make sense? You could make the tangent line in terms of a's and t's if you wanted to. That'd be fine. But if I was going to use y's and x's, that's what I'd do. Does that help?
Yes.
Okay. Thank you. Any other questions? Follow-ups? Did anybody do part A totally different but still got the right answer? That's Peyton, right? Yeah. Yeah, how'd you do it?
We took the integral of the derivative.
There you go. Yeah. So integral from 0 to 30. And then did you have 1/30th out here?
Yeah.
Of A prime, right? Yeah? Yeah. And so if you do it this way, this will actually work out great as well. You have to know how to find A prime to do this, but if you do, it's actually a really good setup. If you notice, if you do this symbolically, here's what happens. Isn't the antiderivative of A prime just A? So this would give you 1/30th times A of t evaluated from 0 to 30. And doesn't that, when you do FTC1, give you the exact same thing as what they had? So you'd get A of 30 minus A of 0 times 1/30th, aka over 30. So it's the exact same thing, but you approach it from that perspective. They approached it from kind of a secant line slope perspective. Your way works just fine too. Thank you. Any other follow-ups on any of these, A, B, C, or D? I don't know. That's fine. $35.054.
So would I, so like I didn't write an actual expression for L of t, but I like found it without the answer. So
What
what
is
You got it right. So you got it right here.
How do you do
That's it.
the integral of
That's definitely it.
Okay, and then I didn't, oh, and then me plugging that in would be the other part.
like how do you get an integral?
Because you replaced L with 0.5. Yep. Yep. Nice work. Any other follow-up questions for
How much I was
grass
off by,
clippings?
which is
Okay, so on to the one, I believe it's like an area and volume for AB. BC has a option on this one. Check it out. Okay, there's A and B. We can look at C in a second. So you can see that for A, if the calculator is active for A versus not active, it changes the nature of it significantly. Did anybody for A remember the deal from yesterday where you can stop well short of like a totally simplified answer? You could have something like that and it's fine. So consider. For B,
On B, are we allowed to stop? Okay.
that'd give you full credit right there. Since F and G are previously named.
Yeah.
So there's no reason to go on to that second line. So F and G, think that's what everybody? Yeah. Hey guys, could I have your attention real quick? I want to talk to you about A. Hey guys, listen up. Hey, listen up. So, I just want to be as balanced as possible here. So, for part A, like I mentioned, I think hopefully this would make sense from yesterday. Like if you stopped right here, that would definitely give you full credit, and I would suggest that you do something like that. However, if you stop here, it might feel like that's just as good, but it's not. What's the step that you got to take to get from here to here? Yeah, isn't that part of FTC 1? And so if you're going to leave off FTC 1, you are definitely not doing a calculus thing, which is something you're being assessed on. So you definitely would want to keep going to this stage right here, but there's no reason to get to that stage of an answer. Okay, and then here is the answer for, and the points for C. Again, look that over. Try to score yourself. You guys have any questions on the area volume question?
You know, like on the pieces of California, she just says that I had releases. Yeah.
Do you know the song? 99 Love Bones or whatever? It's like German.
Anybody else have a question, thought on area volume? Okay, those who want to final one has to do with some trains.
Or do you, like, do you want to?
Yeah, somebody already asked me about that one.